Welcome to Z-Tech Almanac. Today we'll build a HiFi tube power amp. It's going to be 50 watts per channel and it's going to be built out of 4 EL34 output tubes and 12AU7 and 12AX7 preamp tube. This circuit is something that I've tuned and worked on for several years. I built several of these amps. I have one of these in almost every room. And I really enjoy the sound, and especially the sound of these amps. It's hard to kind of find the sound that you like, and so I've taken a lot of time tuning the capacitors and resistors in the circuit, which I really enjoy with these tube amps because you have lots of leeway to tune these circuits and to try to figure out what sounds good, and at the same time make sure that your THD distortion is also very low. Which for this amp, we're going to be looking at somewhere in the 0.1 to 0.5 range of THD distortion depending on the power output level. And so the amp's going to be working in predominantly Class A, and we'll talk a little bit more as we build the circuit around biasing and all those things about Class A, Class AB and such. But yeah, it's going to be a fun project, and even though I built many of these, it still takes a little bit of care and focus to make sure that I don't forget some of the details that are needed. And so I'll walk you through some of those details, some of the tricks that I've learned over the years of building these amps. They're sometimes a little bit tricky to get right, and make sure you eliminate hum and do all the right things to make sure you have a very quiet amp and all those things. So let's get started. So today we're going to build a 2 times 50 watt per channel tube amp, so 50 watts per channel basically. And here I have the block diagram for it, and you might be asking, where's the schematic? Well, the schematic is like a secret family recipe. I've been tuning it and tweaking it for years now, so I'm not going to share publicly, but as you watch the video, you'll glean some insights into how this is all put together. There's nothing super special about the architecture of the amplifier. What's special and what I want to keep somewhat close to my chest is the component values and exactly how everything is tuned, right, for the sound that I want. The power transformers here. So we got three secondaries. And depending on what transformer I use, there might be some different combinations here. For example, for the circuit we're going to build today, I have a separate transformer for the 50 volt AC bias. So the first thing on the secondary is a high voltage 300 volts AC, which gets rectified and filtered to 420 volts DC. And that's the my main supply for the amplifier. Then we got the 50 volts AC that goes into a rectifier again and a bias circuit. This is a negative voltage, so it's gets rectified to negative DC volts, right around 40 to 50 volts or so. And that goes to the grids of the output tubes. So we're gonna have 3 or 4 EL34s output tubes, and we're gonna have 4 outputs here that go to each of those tubes. And then finally we have the 6.3 volts AC filament supply, which is balanced grounded here just to reduce hum, and that goes to all the filaments of all the tubes. In this circuit I think I have these 2 separate 6.3 volts AC secondaries, in which case I'm just going to separate out the left and right channel, and that helps a little bit with crosstalk. Very small amount, it's almost immeasurable, but anything that helps to kind of reduce the left to right channel crosstalk is a definitely positive thing. Okay, so the circuit itself, or the amplifier circuit itself, it consists of 2 preamplifier stages, so a 12AU7 and a 12AX7 stage. So this is a pure preamplifier. That's a preamplifier and a phase splitter, 12AX7 tube there. The voltage to these is dropped with the resistor capacitor filter here, so we're not supplying the full 420 volts DC to them. And then finally the 12AX7 stage drives the 2 EL34 output tubes in push-pull configuration. And then finally the audio output transformer is hooked up there, and then we're going to have the output right there, which I ran out of paper and didn't draw the speaker, but the speaker goes there. And then finally we have the negative feedback circuit that connects us from the speaker to the first preamp stage. So all in all, pretty standard architecture and configuration for the power supply and the amp. And we're gonna you'll see, we'll get into some specifics as we build the circuit. I'll talk a little bit more about how the power supply works, how the bi-circuit works, how the amp works. And you'll be able to glean a little more information about if you want to build something similar, to be able to build something like this. And then you can kind of go through a similar process of tweaking and tuning some of the components to the sound that you exactly like. And I think that's almost a personal choice, right? Of enjoying that process of tuning the sound to your liking. So this will give you a great start in that regard. Okay, well, let's get started with building the amp. First thing we're gonna do is look at the chassis. This got shipped to me a couple days ago. I have these made externally because I don't have the tooling to make chassis here, and I like to have a very, very professional look to these. And so they're properly painted, properly designed, and I found a good place to make the chassis. And that's the most important part, really. The chassis is what makes and breaks a project like this. And from shock hazard to proper shielding, the chassis plays a huge role in to make sure that you get everything built correctly. All right, well, let's open this up. Okay, so here's what it looks like. So we got the cutouts for all the tube sockets here, and I got two output transformers here, the left and right channel, and then I got the power transformer going there. And then front plate there, and on the back we got all the holes for everything else: power, speakers, left and right, and then the inputs, left and right analog inputs. And then the bottom has a bottom cover that we'll just remove here, and we'll see how the inside looks like a little bit and see if everything looks good. But so far everything looks great. So when I designed this chassis, I wanted to make sure that it's held together well, given the weight of all the transformers. So I put a whole bunch of screws on the bottom here to take the bottom cover off. And so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws. I don't even know how many I got, but I got, make sure the corners are held in really well. And make sure, obviously the front is held in, the back is held in. So just make sure that the weight is well distributed across the bottom, because the bottom is going to be obviously holding up the whole amplifier. And so I want it to be strong. I want it to be, I don't want any sort of vibrations, right? So when you play the audio kind of loud, you don't want the chassis and components inside to be shaking around and vibrating. So that's one of the reasons I want the bottom to be on there really solid. So just taking off the screws here and see what's inside. Taking the bottom off here. That's how it looks like there, and put it on the side. So you can tell, the inside kind of looks like that. Nothing else is in there. You can see the tube sockets and all the transformer holes and everything else there. And yeah, so everything looks good. Usually I don't have any problems with these chassis. They're making them really good, and per my specifications. So I don't find anything off with these. So okay, well, let's get to the next part. We'll start putting on a couple of components here. I think I'm going to start with probably the power and some of the speaker terminals first, and kind of see from there maybe the tube sockets and transformers, and it doesn't matter which order, but I like to put a few components in there before I start, obviously, building the circuit. So okay, here's the fuse holder, and that's an easy one to install. Just do that, and just screw that on there. And for these things that kind of rotate, and I put a little glue on there once I'm all done, and I glue it down just a tad. It's not for it to hold it for excessive force, but just an extra amount of a little bit there to hold it enough where if somebody takes the fuse out, it's not going to come loose, but also not too much where, if you want to change it out later and replace it, then it's not so much glue that you can't take it off. The next thing that is the next most important thing is the speaker post. So these are going to look like this, and I have a 4 ohm, a ground, and an 8 ohm football channel. So they're just going to go like that. They're insulated, of course, from the chassis, so there's this plastic insulation that goes on there. And then there's a nut that goes like that. So no big deal there. But what I do that just to make sure everything is good is that I put a screwdriver into the hole on the other side just to keep it upright, because I want all these speaker posts, holes on the other side to be upright and even, of course. And also this helps to hold it down, or I'm going to just use a wrench to tighten it all up. Alright, what else? Okay, the next thing is going to be the Rca Jacks. Kind of look like that. And I have a left one and a right one, and so make sure that I have the red color for the the right channel. So kind of like that, not a big thing. Also screws out from the other side. And these I've gone back and forth around. Hey, needs to be chassis isolated or not? It really doesn't matter. What I do is anyway have a ground resistor from the amplifier ground to the chassis, couple hundred ohms, and just in case that doesn't ground it enough. So it's one of these analog things that you want some chassis grounding, but not necessarily like 0 ohm chassis grounding on the input. But it really doesn't matter, and I haven't heard any hum one way or the other. So, but yeah, I tried it both ways with the Rca input jacks, and they work. They sound great either way. Okay, so I'll continue doing this. I'll leave the switch, which is here, last, because I'm going to solder some wires on there, just to make sure that when I hook it all up, I don't have to get in there and solder in a tight area. So we'll do that last, and we'll do it with the power plug, and that's I decided I'm going to kind of keep that to a later stage. One little trickier bit is the ground lug that goes right there, and that has to make a 0 ohm connection, or 100% connection to the chassis. So because this is powder coated, I need to, and that's kind of an insulator, I need to just dremel it down just a bit before I put on the ground lug. So just gonna get in there and dremel that down. And then here's the ground lug. Just goes on the other side here. Kind of just across here. And that's all it is here. Just put a screw on. And I'm going to just solder some terminals on there, and that's it. As I'm hooking up the power, there's one important note I wanted to mention. Here's the power switch, and this is a double pole one. It's probably the safest thing to do here, just to make sure that there is a polarity switch on the power line. This switch safely switches off both the ground or the neutral and the hot line. So use a double pole switch. But most importantly, the way the power needs to be hooked up here is that the power is going to come in through the power outlet, first go to the fuse, which is hooked to the hot line, then to the switch, in that order. So if something were to happen with the switch, it's not the first thing in the circuit. So the fuse, basically protects everything. So, power, plug to fuse, then to switch, and then to the rest of the circuit. So that's the way I'm going to hook it up. So I might as well put the switch in there because I've soldered, all the wires onto it. So just snap that in there, and easy as that. And so that, just want to take a note on that. Otherwise, I've fastened everything here, and nothing special there other than what we talked about. So the back panel is done. I've also added a little bit of glue to the fuse holder and the speaker posts. And as we talked about, the switch is sort of the output of the power to the rest of the amplifier. So we got the input at the power connector, goes to the fuse, and then from the fuse goes to the switch, and then we got the hot and the ground of the AC coming in there. And I'll hook up everything else to that. What else? The ground of the power is connected to the chassis ground directly. There's no other resistance or anything else. But we will have a little bit of a circuit there to, from the chassis ground to the circuit ground there. So I'll show you that as we start building out the circuit. So that's done. That's it for the back. Next up is gonna be the tube sockets and terminal posts, and maybe I'll start adding the transformer. We'll see. We'll see which way do I feel like going. But definitely the tube sockets are gonna be the next step. So I flipped the case over to show you the tube sockets all installed. The way I like to put these in is that they're basically mirroring each other. So pin one of this one's here, and of that one's over there and there. So basically, think of the tubes are facing each other for the left and right channel. And there's no real scientific reason for that. It's just kind of like it the way it looks as I put the tubes in, to have a little mirrored look where put the tubes in one way, the other way. And there might be a slight coupling advantage, but I'm gonna say that's probably hearsay at this point. But I do like to kind of keep the left channel pointing this way and the right channel pointing that way, and that way it just looks a little nicer and it looks a little more symmetric. I've done it both ways. I've done it where the preamp tubes are facing one direction, or the power tubes are facing one direction. I obviously didn't hear any differences, but kind of I settled on this approach of mirroring the tubes, the tube sockets and the tubes, and so I'm sticking with that, I guess. I've completed the filament wiring. You can see this black twisted wire connecting the filament pins for the preamp tubes and the output tubes. Two important things here to mention is they have to be twisted, although you don't have to go crazy overboard with it. But twisting helps reduce hum, and also pressed against the chassis as much as you can, again also to reduce hum. Other than that, there's not a whole lot to it. Some people get into twisted counterclockwise and clockwise and this and that, the other thing. It really doesn't matter because today's power transformers and tubes are well made and well balanced, and so you are unlikely to get hum from the filament wiring. You will probably get hum from other sources, and so we'll find out if we can counter that with this amp, but unlikely it's going to be filament wiring. Okay, and one more thing. The reason I have it separated is because my power transformer has two separate filament secondaries, and that's why I put them on separate circuits. But either way is fine. Having them on single circuit versus a separate circuit doesn't make any difference. So here's the power supply circuit board. This is pre-assembled. I have these pre-assembled. So I'm not going to go through putting these together. It's pretty simple to put together. Not a big deal here. These are the power supply filter capacitors for high voltage. The high voltage comes in here. We have 4 diodes that rectify it and then goes through the left and right channel filter capacitors. In the center here, there's a delay turn-on circuit, which helps increase the life of the EL34 output tubes. And the way that works is when you turn on the amplifier, the filament voltage is applied to the tubes, they warm up, and about 30 seconds later, this circuit kicks in and turns on the high voltage as well. So it just delays the high voltage to the tubes. And then here we have the bias circuit, and so there's about 50 volts AC coming from a bias transformer or secondary. Sometimes depending on what power transformer I use. And then it goes through here, and we have the bias settings for the 4 output tubes by these 4 trimmers. And the bias I'm going to set, and we'll go through that tuning much later when it's all done. I'm going to set to about 35 milliamps per tube, for EL34 at least. That works up nicely at this voltage and for this amplifier with the given negative feedback, that there's zero distortion, there's zero effect on the audio by setting it to 35. So that's sort of the sweet spot that I found that is works the best. If you're familiar with Macintosh amplifiers, for example, MC275, their biasing is fixed and it's a very low current. So that's why they claim there's no biasing. In fact, there is, but it's very low. So, and the way they work around it, quote unquote, is they have a massive amount of negative feedback in multiple points in the circuit that fixes that crossover distortion due to the low bias current. Here we have a little bit of negative feedback, but not enough to be able to afford a very low, bias for the output tube. So that's how I ended up with 35 milliamps by looking at the amount of negative feedback and the distortion and kind of finding that sweet spot there. Okay, finally, we have 4 LEDs that are just there for decorative reasons to, give some color to the chassis from inside, so it will light up nicely. Back to the chassis. I installed a power transformer right here. The wires are not hooked up yet. I'm just going to hook that up once everything is in place. We got 120 volts AC input here, and then we have the high voltage AC output plus the filament output right there. Okay, so I installed a couple of more things. First is this bias transformer. This puts out about 44 volts AC, which should be plenty for us for creating a negative DC bias voltage. I've also added these terminal strips for putting the components there, these 2 here. And I've added the bias meter 3.5 millimeter jacks. And what these are really, they're just connected to the cathode of the output tubes with a 1 ohm resistor to ground. So it measures the, so you can put a DMM, you can hook up a DMM to it, so you can measure the voltage across that 1 ohm resistor and determine the bias current. It's just a little easier to plug something in on top of an amplifier than having to get a bias meter where you have to unplug the tubes and replug the tubes, so it's just, less hassle that way. I'm kind of contemplating what to do next. It's always I change my order a little bit. I think I'm going to go with hooking up the speaker terminal wires to the output transformers and put the output transformers in. That way, it's just a little more room. There's a little more room now to hook up those output transformers, at least the outputs of the output transformers, and then maybe I'll put the power supply PCB in afterwards, and then I think the last thing is going to be building out the amplifier circuit. I usually leave that to last, or almost last, just to make sure that everything else is in its right place first. Okay, so I've installed the output transformers. You can see them here. They're screwed in or bolted in, and here's the other one. And I've soldered the speaker outputs of the transformer to the speaker posts here with these wires. So remember, we have 4 ohm ground, 8 ohm, and then 4 ohm ground, 8 ohm. It may be the other way around, but either way. One of them's 4, the other one's 8. And 2 notes on this one. One is the mounting. So the output transformers are potted, and the reason they're potted is that they don't vibrate and they stay very solid mechanically when you have a high amount of audio frequency going through them. So that's good, but at the same time, they need to be very solidly mounted to the chassis. So when fastening these screws, like this one and that one and this one and these screws over there, I use pretty big screwdriver, as big as I can get, that fits in there. 2 hands and the whole body to really make them really tight. And that's important to really mount those to the chassis and really build that solid mount for all the transformers. And the weight matters, and all this stuff matters to reduce the mechanical vibrations. The other thing is the soldering. I've soldered these wires and the output transformers and the speaker post with a 230 watt soldering gun, and even that you have to hold it on there for a while. And I use plenty of solder, and sometimes it drips, and that's okay. I'm a big fan of using more solder than less, especially here where you want to have all the strands of these wires soldered and connected to the speaker post and to the transformer. So that's a low impedance output, meaning low voltage, high current, and want that really solid connection. Obviously, also short wires are important there as well. When we start building the rest of the circuit, you'll see that I'm using also quite a bit of solder everywhere. And the idea there is that, for different reasons there, of course, tubes heat up really hot, especially these pins will heat up to really, really hot, almost to the point of melting the solder. So if you have a tinsy solder on there it's just barely enough to make a connection, and it looks very nice, and it's all that, that's a high risk for tube amps, right? Because you get a little bit of heat, a little bit of mechanical movement, and all of a sudden that solder joint breaks off, and you have a broken amp, right? So I use as much solder as I possibly can, without obviously overflowing and making shorts and everything else. If it drips, it's okay, I clean it up. But the more solder there, or the larger amount of solder there, even though it's not pretty, it helps in ensuring that the circuit's not going to break with heat. So, if the tubes heat up and the solder is just about to, sort of lose its sort of viscosity a little bit, it still will hold on, and the large blob of solder on there is going to keep this amp functioning for years and years and years. I mean, the first one I built, one of these, is probably at least 12 years ago, and it's still working, no problems, haven't had to fix it at all. And that's the way I want to build these amps. And let me show you how I solder on a resistor here. So this resistor, and hopefully it's visible, has, I cut the lead so that there's a little hook, to create a little hook at one of the other ends. And what I do is I put the hook into one of the pins of the tube. So this is pin 5, and the resistor goes in there. And so this was a little easier to solder the first component. Now, subsequent components, I don't have to put the hook, I just solder it on there. It's a little easier. But the first one, I found it is difficult to kind of hold it in there or try to put it in, and it slides all over the place. So the hook just lets me hold it there, and I kind of pull a little bit on it. And then I'm going to try to do this around the camera here, solder this, and I can just put some solder on there, and then get that solder. Of course, I'm going to put way more solder than that, so make sure that we have plenty of solder. Alright, that's a camera soldering there around the camera. But hopefully you get the point of basically the hook helps kind of have that initial kind of hold there. And it's not for a better soldering joint or anything, that is just for mechanical stability. So as I hold the component, it doesn't shift around and slide around, and I can solder it real nicely. So building the rest of the circuit here, what I've added here is a filtering capacitor for the power supply coming into the preamp tube, and I've added the input circuit there. And as you can see, I'm using obviously the terminal strip here to attach everything. Many people put all the components on the strip itself and kind of make it a big sort of layout there. I like to keep all the resistors and other components close to the tube to reduce the wire length, and especially important for high impedance inputs for the tubes, just to reduce noise and hum and all those things. And so that's why I do it this way. Again, the goal here, at least internally to the amplifier, is function over form. And I'll explain that a little later, exactly what I mean by that. And obviously, external with the amplifier, it needs to be, it needs to be looking nice. So that's actually a form over function, or form first, I guess. So, but as you see the circuit built out, it will look like a rat's nest, and that's by design, right? I've done circuits where all the wires are zip tied and they're 90-degree angles and they're straight and they're, they don't run along the chassis in a neat way. Well, what happened in some of those circuits is that there was a lot of feedback and the wire lengths were too long, right? And so some of the high impedance wiring picked up hum and noise and crosstalk and feedback from the other channel. And so, plus you're running the risk of, arcing, right? So if you zip tie wires together and there's a voltage difference between them, the insulator is going to be fine, the next year, 5 years from now, 10 years from now, but maybe 20 years from now, that insulator might break down just a tiny bit and those wires will arc. So, having this built as a rat's nest, meaning that we need to have the shortest wire from point A to B, is actually beneficial for, multiple reasons. Obviously, it doesn't look that great, but again, the function and the durability and making sure this amplifier lasts for a long time is more important, right? We're going to cover the case up anyway, and no one's going to see that unless you open it up. So the key thing there is make sure that we build a solid amplifier. Here's the first preamp stage completed. Let me explain what's going on here for just a sec. So this is the audio input to the amplifier and to the first preamp stage, of course. And then I have basically one half of this tube hooked up as the first stage of preamp. This red wire here is the output of the first preamp stage, and that's going to connect to the second preamp stage, which is going to be this tube here. And we're going to use the full, both halves of that tube there. So next I'm going to assemble that, both halves of it, basically connect this to that, and then that preamp stage is going to be the final driver for the two output tubes. So basically, one of the channels just consists of these 4 tubes, 2 preamps, and then 2 output EL34s. It is time to install the film capacitors. But before we do that, we need to actually determine the polarity of them. And these capacitors are, of course, I'm joking that they don't have polarity, but it's still important to place them in the right, with the right polarity into the circuit. And the reason being is that because the capacitor winding it goes around like that, and there's an outside foil and an inside foil lead. So one of these leads is connected to the outside of the foil, and the other one's connected to the inside, the center. And so we want the outside foil to be the low impedance point in the circuit and the inside to be high impedance point. This provides additional shielding from hum and noise, right? So one way to determine that, which I've already, you can see I've already cut the leads of the capacitor, is that I hold up the capacitor and I look at the waveform on the scope and kind of make a mental note of how many millivolts it is. So it says about 2.6 or so millivolts. It kind of jump up and down. And then I reversed the leads here on the capacitor. And then here I got like 6 point something, 7 millivolts. So obviously this is the wrong polarity the way I have it now, where the ground is connected here and the signal of the scope is connected there. So the correct polarity is this way, which is the ground being on that lead of the capacitor, which I already cut a little shorter, so I basically just cut that a little shorter to indicate that that's the low impedance end. And then I have the high impedance end connected here, and that I left that lead longer. And so that's one easy way to determine, which way these capacitors should run a circuit. And and some have extra shielding actually. Some don't need this sort of test. let me show you. I have another capacitor here that, if I hook it up basically this way, so let's just hook it up one of the ways. This is really well shielded, right? So you can tell the difference between this capacitor and the other one. You can barely see anything, if anything at all. And I have the scope on the maximum sensitivity. And then I'll flip the polarity here, or flip the scope leads. And same thing, meaning nothing. So this is a really good and well shielded capacitor. And what they say in the manual is they call bifilar wounding, basically, which helps with the shielding. And which I can tell here that we're not having anything filtered through any 60 hertz hum comes with this capacitor. So this is a really good one, and I can truly hook this one up either way. This is truly a good capacitor that I can reliably hook up either way. So I don't have to worry about this one, but I do have to worry about the orange drop capacitors, these ones, to make sure they're hooked up the right way. Okay, well, let's get back to the circuit. Okay, so the preamp stage is all done. We got the first stage completed from previously, but also got the second stage. The second stage is, we use both sides of the tube, and it's the second stage of the preamp stage plus the phase splitter. And I got all the power wires also hooked up, so ground and plus voltage wires. So these red wires are that. And I've added, of course, the coupling capacitors, the orange drop, and the black ones, the soldering capacitors that we just went through measuring. And nothing special here other than making sure it looks like a rat's nest. It should. We want to keep the wires kind of going straight to their destination and fairly close to each other, obviously without touching. And also what I've done is I think I mentioned this before, but basically I soldered the center of the tube socket to the ground. So there's a little center tube socket to ground wire. And that's just an extra way to shield and reduce noise and hum in the amplifier. So just an extra touch there to make this as quiet as possible. Alright, so next is going to be hooking up the output tubes, and then hooking the output tubes to the output transformer. Making some more progress. I've hooked up the outputs of the preamp, which are these two capacitors here, to the primary grid of the two output tubes, the EL34s. So this is just a coupling cap, and we have a 10K resistor there to the primary grid. And I started also hooking up the bias measurement jack here, and that's a simple hookup where one side goes to the ground, which is here, and then the two other sides go to the the cathodes of each of the EL34s. So basically it's measuring that voltage across this 1 ohm resistor. So next, output transformer hookup, which is going to be here. We'll do that, and we should be maybe 90% done or 95% done with stage here, and then we'll start power hookup and all those good things, and double checking everything, right? This is the time to double check things, make sure nothing's forgotten. The last thing you want is to turn this thing on and go up in smoke. So I always double check several times, even along the way, to make sure things are hooked up correctly. Okay, so we're pretty much done-ish with the amplifier circuit. The last piece here being hooking up the two EL34 output tubes to the output transformer. I say done-ish because the power connections are not done yet, so we still got ground and the positive power to hook up to both output tubes and the preamp stages here, but that's going to come as a final step there. So these red wires hook up to the output transformer there. That center tap will be the power input for the output transformer. And then one note about this little transformer here, and you might say, well, the wires are kind of close. That's not gonna be a problem because these wires are fairly low impedance, even though they're, you know, on the high impedance side of the output transformer. We're talking, you know, single digit kilo ohms. And the other thing is that this transformer, you know, is a bias transformer, so it draws very little current, and thus it creates very little magnetic field, even though it's not necessarily a toroidal or shielded transformer there. So nothing to worry about here. You know, obviously the wires are still pretty far away, and you know, the trick's gonna be this section here where things might hum or other stuff might be picked up, especially this first tube. So you know, this has not been a problem, this vicinity here, but you know, every circuit as I build it may be a little different, and we might have to fix the hum as we tune this amplifier and do the final testing and listening session for it. And usually there's very easy fixes for that. So we'll go through that if that's an issue, but I don't think it will be. Next, I've hooked up the ground wires as well. So these are these black wires connecting all the grounds together. So we got the 4 output tube grounds hooked together. So there's 1, 2, 3, 4. And then I got the grounds going to the preamp stages as well. So this black wire goes there, and then the other one goes to the other side. And one thing about ground, and this is a well-known thing just to reduce hum, is that you want to use star wiring. So I chose this point to be my central ground point, and all the ground wires you know, start from there. So basically there's no other loops or sort of center points, and so you see that the tubes are grounded, the output tubes are grounded starting there, but also the preamp stages are started from there. They go here, and there's one more hop there, so it's all in the same line. So there's no circular hops. Definitely want to avoid loops. That's a no-no for avoiding hum. And then on this side too, it goes to the other side, and it has another hop there. So that's all it is, and you know, it's pretty simple once you kind of design your circuit and kind of find that central point. Just all the grounds have to go there. So when I put in the power supply board, the ground's going to connect right at this point, and then you'll see that solder joint will get pretty big, and that's the one I'm using the 230 watt soldering gun for, just to be able to even melt that, because there's just so many wires connected to it. The rest of them can be done with the smaller soldering iron. So, but these are thicker wires, plus quite a few of them joined there. So, want to make sure that it makes a really good connection. So, don't be shy on the heat there, and making sure you have a high wattage soldering gun. All right, so the circuit is complete. As I mentioned before, I finally did install the power supply board, circuit board here, and I've connected all the 120 volts AC wiring to the transformers, and anything that's AC, it's twisted. So you'll see all these twisted wires. That's AC. This is the high voltage AC wiring coming out of there. So that's good. Then I connected the bias transformer here through a green wire to the bias power supply, and then I have the 4 bias DC voltages going to the grids of the 4 output tubes. So these 4 red wires are the bias voltages, or bias wires. And then last thing was, I double checked, and sure enough I missed some of the grounds, and so this is one thing to check to make sure all the grounds are connected. So I have a ground coming from power supply circuit board to the star ground point here, and then I have a ground coming from the power supply circuit through a 220 ohm resistor to the chassis ground. And I separated those grounds via that resistor so that you know, we have the ground currents in the circuit stay in the circuit, and then we have ground currents in the chassis stay in the chassis. And then the last thing is that because there is some negative feedback, and these are the negative feedback wires here, I need to have a closed circuit from the speaker terminal negative feedback to the speaker ground. So the speaker grounds also have to be grounded, and that's usually what I forget. And so here the speaker grounds through this black wire are grounded to the star ground as well. And that's not a big deal if you forget that. It's just the amplifier is going to sound louder and maybe a little more distorted since there's zero negative feedback. And some people like the no negative feedback sound, but I prefer to have a tiny bit of negative feedback, and that helps with the output impedance of the amplifier and helps with just the kind of sound I like. So that is more of a preference, and that's one of the things I've tweaked and adjusted over the years with this circuit. Other than that, it should be ready to go. I added a fuse, so we're gonna flip this over, and I'll add the tubes in. I will set the bias voltage to the highest negative value, so that when I turn it on, I have the minimum current going through the output tubes. And then I'm gonna, for the first turn on test, I'll kind of stay far away, just because if I did mess up any wiring, or if there's a short somewhere, or whatever issue there is, some of these big capacitors could pop, for whatever reason. So you don't want to be sitting here 10 inches from the circuit board and turning on the power for the first time. Definitely don't do that with capacitors and circuits you haven't tested before. So that's one little trick that I do for your own safety. Stay away and just wait for it to turn on. And the nice thing about the circuit is that I have this delayed relay here that when I turn the power on, the high voltage or the high voltage is not being applied to the circuit yet. So I have a solid 20-30 seconds to get away, far enough away if any of these capacitors happen to pop. Okay, well, let's get to the next stage here and see if this thing will turn on and work. Alright, so the tubes are all in. The speakers are hooked up. Sometimes I hook up a speaker, sometimes I hook up just resistive loads to the output, but in either case something has to be hooked up. Tube amps don't like to have open speaker outputs. So place all the tubes in, make sure everything's seated well, as I mentioned previously, the biases are set to the maximum negative voltage, so we should see a low current through the tubes. Now I'm going to turn this on for the first time, so you'll see it with me here if anything blows up. But the thing I'll be looking for, if any of the power tubes are red plating, which means that the bias voltage is either not hooked up or it's zero, or we have some biasing issues. So that's one thing, unless something else pops before then. So we could pop the fuse or one of the caps and things like that. So hopefully none of those happen. And so here we go. I'll stand back a bit. Then you'll see that we'll wait for that couple of seconds for that relay to turn on. And so I got the relay turned on. Tubes are looking good as far as the current. Nothing's red plating. I would have seen them by now if it goes up to 100 milliamps or so. We got good heater voltage, I see. The yellow glow is there. It's maybe hard to see through the camera here, but that's a pretty nice yellow glow. Let me turn off the lights actually. And, a little better there to see the glow and some of the blue LEDs from underneath the chassis. So far so good. So next I'm gonna look at the bias voltage here, and I'll show you how I measure that. Bias voltage and bias current. Remember, we're going to measure the voltage across that 1 ohm resistor. So how many millivolts we read, it's equivalent to that many milliamps. And so we're looking for 35 milliamps to set the bias for each of these tubes. Okay, time to measure the bias. So I have my DMM here hooked up through that 3.5 millimeter plug. And it's a pretty simple hookup. I have a switch that basically measures the millivolt voltage across either the 1 ohm resistor on this tube or the 1 ohm resistor on that tube. So, and it switches back and forth. And of course I have the meter set to 200 millivolt scale there. And I use these meters that do have this switch, sort of manual selection switch, rather than the other automatic ones, because automatic ones jump back and forth, and sometimes they mispredict if I'm measuring ohms or current or voltage or whatever, right? So definitely try to avoid the sort of super automatic digital multimeters, but these ones are pretty good. You just set it to the scale and you're good to go. So you see there's zero current for bias on this tube. So I'm going to start turning the trimmer here on the circuit board, which is just the negative bias voltage up or down rather, to increase the current. So basically higher negative voltages are lower bias, and vice versa. So okay, so going up, so we need to look for 35 milliamps here, and here is almost there. So there's 34, 35, and it's a little touchy to really get that 35, and it will shift around a bit. So what I do is I go through all the tubes, get them 35, and I go back again one more time. Then I'll leave the amp on for 10 minutes or so. It's already been like 5 minutes at least. So leave it on for 10 minutes or so, and then repeat the procedure again, because as tubes heat up kind of to their working temperature, and everything else heats up in the circuit, right? The resistors and everything else kind of heats up to their working temperature. Things will shift around. So that's why I leave, wait a good 10 minutes and leave it on and see what happens. And sometimes the tubes are bad, like even brand new tubes are bad, and you'll see that bias shift all over the place. And the danger zone is when you left it on for 10 minutes and the bias is 80 milliamps, for example, and that for sure is a sign of a bad tube, or even potentially something gone wrong in the circuit. But once you get to this point where everything's working, the circuit's looking good, and so if things go haywire from here, it's usually a tube that has it's a runaway tube. So we'll see that. We'll check back and see if the biases hold. Okay, it's time for an audio test with the long exposure, a picture of an amplifier in the background here, and let's take a listen.
All your life was turned you out and burned you, held you high off the ground. You touched the moon, then it dropped you down. I know your heart's been broken. Just don't come so easily. It takes time, that's alright. Just let me heal your heart tonight. I will rock you gently. I will be there when the night comes down. I will rock you so gently. I will rock you gently. I will be there when the morning comes. We'll rock. by day, all through the night into the day. I'll be your lover, I'll be your friend. Open up your heart and let me in. I will rock you gently. I will be there when the night comes down. And we'll rock you so gently. Oh, I'll rock you gently. I will be there when the morning comes. We'll rock you. Oh, I'll rock you gently. Oh, yeah. Oh, I'll rock you gently. I will be there when the morning comes. So gently. Oh, I'll rock you gently. I will be there when the night comes down. Oh, yeah, yeah, yeah.
Well, I hope you enjoyed this video of building this tube power amplifier. I thought this was one of the better builds that I had. I went through quite a few of these amplifier builds, and I had to tweak and adjust and fix issues, but with this amplifier today, the circuit was working great. All the voltages and currents are within tolerances. And the sound is also awesome, right? You just heard it has a really great sound, really well balanced, and that took a while over several builds to really tune the circuit to get to the sound that I like. And most people have different sound preferences, but the tube sound and specifically the circuit that I built here is sort of my sort of balanced sound that I would like to hear, right? So I roll off the highs a little bit, a little more punch in the bass, just the way I build a circuit. I don't really enjoy the tube amps that have a huge mid-range, mid-frequency section. I think some people enjoy that more as well, but this amp is a good balanced amplifier between being a really sort of zero feedback tube amplifier and between being sort of a large negative feedback transistor amplifier, right? So kind of a midway in between there somewhere where I tweaked the circuit to my liking. Anyway, I hope you enjoyed the video and the build of the amplifier. If you have questions, just let me know down below. I'm happy to answer them, and I'll see you next time.